Okay, so this is problems 1 through 12, I guess, through 16. And what we're supposed to do is look at these functions, which have only been translated and or reflected. They have not been stretched. So we really just have to pay attention to a few key points. We don't have to check the exact values. So in this case, we're looking at the coordinates of the vertex. And you can see the vertex is this point where it has the minimum value, or a vertex can be the maximum value. And you can see that it has been vertically displaced, but it has not been horizontally displaced. So the form of the equation would be y equals x squared minus 1. So because there's no horizontal displacement, we don't have to deal with that part. We just have to add this additional term. And because it's pointing upward, then we know it's positive x squared. Now the next one's flipped around, and it also is shifted -1 in the x direction and +1 in the y direction. So the form of the equation is going to be negative, so you have a negative sign out in front of the thing we're squaring, and then you'll have x. Now, because I'm moving in the negative direction here, what I'm really is I'm subtracting whatever the displacement is, which is -1. And then I square that whole thing. So I've got negative this whole quantity. And then the y displacement is +1. Now I clean that up a little bit. It would be negative x plus 1, because the negative, or the additive inverse of a negative is the positive number. So you'd have that plus 1. I think I'll put it on one page so I can draw add a little more room. Okay. The next one, you can see it's pointing upward, and it has been displaced 1, 2, 3, 4, 5 units in the x direction and -2 units in the y direction. So we say y is equal to positive, so I don't need to put the positive, x minus the x displacement, which is 5, quantity squared, and then the y displacement, which is -2. And everything's fine there. Here we have one that's upside down, so that's going to be negative the quantity x. So we're going to subtract the x displacement. So this is moved, the vertex has moved 2 units in the x direction, so it's going to be minus +2 squared. And then our vertical displacement is 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So it'll be +6. Okay, the next function is y equals x cubed. And so this has the characteristic shape. And again, we're not stretching it or shrinking it. So y equals x cubed kind of looks like that. So if I were to reflect across the y-axis, it would look like that. And also, if I reflect it across the x-axis, it looks the same thing. So the reflection can be represented either way. And it turns out they turn out they're equivalent to each other ultimately. Okay, so this thing is like the red curve. So it's been, like I said, you can put the negative sign out in front or inside. I might actually show that just to show you that it does work. So this is going to be the x-axis reflection, and this will be the y-axis reflection. And hopefully we'll show that they really are the same ultimately. Now this has just been moved 1 unit in the y direction, no units in the x direction as far as this key point where it changes from one direction to the other as far as the curvature. So for the x-axis reflection, what we do is you put the negative sign outside. Make sure I'm doing this right. Yeah, you put that outside of the parentheses. So you have negative the quantity x cubed, and then it's shifted 1 unit in the y direction. But positive x cubed is just x cubed, so you get negative x cubed plus 1. With a y reflection, what would happen is you would put the negative sign inside, but negative x cubed is negative x cubed. Because what we're doing here is you have negative x times negative x times negative x, so we multiply the x parts together. And we get x cubed, and then we multiply negative 1 times negative 1 times negative 1, which is negative 1, so it becomes negative. So you can see that they are the same. Okay. Now the next one is this one, 6. So there you can see it's like the blue curve, so it's the standard x cubed, so there's no reflection. And you can see that we have a x displacement of 1 and a y displacement of 1. So what we do is we put a parenthesis, left parenthesis, x minus the x displacement, which is 1 cubed, and then we add the y displacement, which is 1. So that's 6. Okay. 7 is one of these that's flipped, so it's going like this one, but it's shifted differently. So this one has 1, 2, 3. So we go minus 3 this way and minus 1 that way. But it's also reflected, and it's reflected across either the x or the y. So we're going to do the x reflection here, and we'll do the y reflection here and show you that they really are the same. So the x reflection would look like this. You'd have y is equal to negative the quantity x, and then we subtract the x displacement, which is negative 3. We cube that, and then we add the y displacement, which is negative 1. So you'll get negative x plus 3 cubed minus 1. I'm going to leave a little space, more space in here, because I think we're going to try to show these are the same. Now, what the alternate version is we don't put the negative side out in front, but we put the negative inside. So it's negative the quantity x minus negative 3. And then minus 1. So the negative, instead of being outside, is inside. But if I have negative x plus 3, so this becomes x plus 3 squared minus 1. But again, you can use the properties of exponents to take basically negative 1 times cubed and this cubed. So that's the same as negative 1 cubed times x plus 3 cubed minus 1. But negative 1 cubed is just negative 1. So you can see that I get the same result, whether I do an x-axis or a y-axis reflection in this case. So that was 7. And then 8. Let's see. You got to be careful. Yeah, it's hard to see, but it's actually 2, 4, 6, 8. So the scale is different. So here's the point, and the Y scale is 2, 4, 6. Pretty sure. Let's go to one page here. It's just, yeah. So it's -2. So this point, the point where it switches, is going to be 7, comma -4. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. So that's the position of the vertex, and it's in its standard orientation. So it's going to be y is equal to x minus a negative of the x displacement, which is 7 squared, and the vertical displacement is -4. So we can remove this parenthesis and just make it x minus 7 squared minus 4. So that's how those work. Okay. So the next group are these absolute value functions. Now in this case we don't have well, I think, yeah, we could possibly have a y-axis. Well, if you think about this, if you have a y-axis reflection, it's going to look the same kind of function. So this is, again, your standard absolute value function. So you can see the first one is just vertically displaced by 5 units. So number 9 is +5 in the y direction. So it's going to be y is equal to absolute value of x plus 5, because there is no x displacement. Here we move 3 units. Let's check the scale here. Yeah, -3 units from the origin to the vertex. So, but we're going to have the negative sign out in front, because that's what happens when you have an x-axis reflection. And then we also need something inside. So we're going to subtract the x-axis translation. So that's -3. And there's no y, so we don't have to +0. And so ultimately have -x plus 3. Negative the absolute value of x plus 3. Okay, 11. Let's look at that one in a little more detail, closer up. So let's see what our scale says. So this point, which is going to be 2, -4, is pointing upward. So that means it's going to be our standard looking absolute value. So you're going to have you don't need a negative sign up front. The x displacement is 2, +2, and the y displacement is -4. So we get x minus 2, absolute value of x minus 2 minus 4. And then the last one here, it looks like the scale is 1 unit per block. So the coordinates of that point are 5, -1. 1, 2, 3, 4, 5, -1. And it's upside down, so it's going to be negative the absolute value of x minus 5 minus 1. Or 1 negative the absolute value of x minus 5 minus 1. Okay, our last function is the square root function. So a standard square root function, let's draw that, remind what it looks like. It's always positive. The domain is positive numbers and the range is positive numbers, so it looks kind of like that. If you rotated this thing, it would look like part of a parabola, but it's the other direction. And so this is the square root of x, I just realized. So if you have something that looks like this, this is y-axis. If you have something that looks like this, you have x-axis. And if you have something that looks like this, then it's x and y axis. So we'll use that as a guide here. Well, this one looks like the standard square root function, and all we're doing is moving it down 1, 2, 3 units. So this is negative 3. This one is at 0, so that one's easy. So number 13 is going to be y is equal to the square root of x, and there's no x displacement, so we just leave it like that, and then we have a minus 3 for the y displacement of this point that starts the whole thing. So that's the point you're looking for to find the translations. That one right there, that one right there. Okay, again, this one has the same upward shape, increasing. The x displacement is negative 1. The y displacement is 1, 2, 3, 4, 5, negative 5. So, and it's because it's this form, we don't have to put a negative anywhere. So you get y is equal to the square root of x minus negative 1, and then subtract 5 from that. And the additive inverse of negative 1 is positive 1. So there you go. 15, this has this form, which is an x-axis. So it starts here, goes down and to the right. Okay, so that x-axis means you put it out front. So it's going to be y equals negative the square root, and the actual position of this thing is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is 5, 5. This one over here was negative 1, negative 5. Okay, so we take x minus this value, and then we subtract 5. No, we add 5. Sorry. So that doesn't make sense. Add 5 because we're going up 5. So we go 5 to the right, 5 up. And we could just take the parenthesis out inside. We don't really need that. X minus 5 plus 5. Okay, the last number is this one. So our displacement is these two moves, 1, 2, 3. So it's plus 3, 1, 2, 3, 4, minus 4. This one is like this one. So it has both x-axis, a y-axis, and an x-axis. So what we'll have is y is equal to negative, the quantity, the square root of negative x minus 3, whole thing minus 4. So this negative sign means that we have a x-axis reflection. This negative sign means we have a y-axis reflection. So we could do that, and then we have negative the quantity x plus 3. Is that right? No, minus 3. Let's just have one minus sign there. So it's minus 3, then minus 4 for the y displacement, and then you could multiply this negative 1 out to these two terms, and you have 3 minus x minus 4. And I'm just going to show you that this is true. You may not believe me, so let's show that it works. So the function is negative the square root of 3 minus x minus 5. Let's double check that's what it said. Negative square root of 3 minus x minus 4. And then we graph it. And then we move it around a little bit. There it is. So you can see it's at point 3 comma negative 4, and it's going that direction. I didn't mean to do that. Anyway, if you look at that, and you look at that, they're the same. Okay. Now, the rest of these are on a separate video. But I'm just going to go ahead and do them so they're in one place. So what we're going to do is we're going to describe the transformation from the common function. So the common function is this. So I could say, I'll call it h of x is x squared. And f of x, what I'm going to do is I'm going to just change the position. Minus x squared plus 12. So what I can say about this is that there's an x-axis reflection because of that negative sign out in front. If it had parentheses, it'd be negative quantity negative x squared, and that would be a y-axis reflection. X shift, well, it's just x by itself, so none. And the y-axis shift is going to be plus 12. So I don't think I've got any graph paper here for that. So let me go ahead and get a piece of graph paper. I'm probably going to have to change the scale to make this thing work. Because we go up to 12 already. So let's make this 20, negative 20. In the x-axis, x direction, I don't need to go that far, so I'm going to say negative 10 to positive 10. And the vertex is going to be at 0, comma 12, because this has 0 shifts. So you go 1, 2, 4, 6, 8, 10, 12. So that's 12 right there. And it's going to be reflected across the x-axis. So instead of going up like this, it's going to go down. And the standard function, you go over 1, down 1, over 2, down 4. 1, 2, 1, 2, 3, 4. And you go over 3 and down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I can use symmetry here to plot the other points. And so if you sketch this thing out, it looks something like that. Okay, next one, 18. So it's already in the form. The common function or parent function is going to be x cubed, because we got x minus 2 cubed. And the transform function is what's given. So what's going on here? Well, this negative sign means x-axis reflection. This negative 2 means x shift of plus 2, because it's x minus h. So h is 2. That's the shift. And the y shift is plus 3. And if we think about the standard function, it looks kind of like this. And the position of this little part right there is shifted by this amount. And it's also then reflected around. So instead of going this way, it's going to go the other way. So let's get a piece of graph paper. And negative 10, positive 10. Let's still do 10. This doesn't shift that much. So what we're going to do is we're going to shift plus 2 in the x direction, plus 3 in the y direction. That's that center point right here. And the way you go away from this is kind of where your symmetry is around. Now normally you'd go over 1 and up 1, but because it's negative sign, it's going to go the other way. So it's going to go over 1 and down 1. So over to the right, 1, down 1, over to the left, up 1. Then you go over to the right. Again, this is your mean middle point. You go over 2, and then you do 2 cubed, which is 8. So 1, 2, 3, 4, 5, 6, 7, 8. And the same thing over here. You go over 2, up 8. 1, 2, 3, 4, 5, 6, 7, 8. So then we can sketch in the graph to look something like that. Okay. Next one's the square root. So the tricky part here is, notice there's no negative outside, and you can't factor out a negative sign across the square root. So that has to stay inside, but we could factor it out. What that means is negative x becomes negative the quantity x, and then we change the sign of the second part to be negative 3. And then we leave the rest of it the same. So if I multiply negative 1 times x, I get negative x. If I multiply negative 1 times negative 3, I get positive 3. So when you have it in this form, you can't, it's very difficult to figure out what's going on here. You always want to, if you have a negative sign in front of the x inside the argument, you want to factor it out. And I'll give you a couple examples in a minute. But what this now says is we have x shift is, so it's x minus h. So h is the shift. So x shift is positive 3. The y shift is negative 4. And because the negative sign's inside the square root, is going to be a y-axis reflection. So we're going to draw it, and then I'm going to plot it using the program just to, again, convince you that I know what I'm doing. Okay, so let's do this thing first. Plus 3 minus 4. Okay, so there we start. And the square root looks like this, and this point here is that point there. Now because I'm reflecting across the y-axis, it's going to look like this. So it's going to have to go up kind of in that direction in general. Okay, so let's think about specifically what's going to go on here. So what you do is you start from this transform port, and normally if you went over x equals 1, the square root of 1 is 1. And then if you went over 4, 1, 2, 3, 4, the square root of 4 is 2. And if you went over 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, the square root of 9 is 3. So I'm just counting 1, 2, 3. And those 3 points will give you enough guidance. Okay, so what we're going to do is we're going to go back to this original function, negative x plus 3 square root. Okay, so it's going to be the square root of negative x plus 3 minus 4, and we're going to graph that, and there it is. And then we can compare it with our plotted function, and you can see it looks pretty good, right? You know, over 1, up 1, over 4, up 2, over 9, up 3. So looks good. Okay, now here we have the stretching question. So we have our parent function, which is f of x equals x squared. Then we have 3x squared. What this does is it increases the y value by 3 compared to normal. Here what it does is the same. It increases this argument by 3, and then you square it. So if you think about if I did the algebra, this really is 3 squared times x squared, which is 9x squared. So this one even does it even more. Now, theoretically, if the number's inside the argument, then you're doing a horizontal squeeze, shrink. So let's do it this way and then think about it that way, because this way is a little easier to plot. And so let's add a page here. Get a piece of graph paper. I'm going to use a little bit larger scale in the y direction. So this is going to be 20, negative 20, negative 10, positive 10. Now there's no translations here, it's just a stretch. So the normal quadratic function starts here at the origin, goes over 1, up 1, over 2, up 4, over 3, up 8, over 3, up 9, sorry. 1 squared is 1, 2 squared is 4, 3 squared is 9. And then you can go the other way. Yeah. Symmetry. Okay, so there's your points, and we could draw a curve there. Well, let's draw it very short. Oh, I messed up my scale here, sorry. We were going to go to 20. I was trying to get it fit more stuff to fit in here. So you go over 1, and so this is 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, so you go over 1, up 1, over 2, up 4, over 3, up 9, over 4, up 16. Then we can do the symmetric parts here, like that. Okay, now we can sketch it in here. Okay, so the next one is 3x squared. So all we have to do is, instead of going over 1 up 1, we go over 1 up 3 over 4. 4 times 3 is 12. Over here, that was, I think I must have messed up here. Let's do this again. No, I did it right. Sorry. So you go over 1, 1 over 2, over 3 up 9. Yeah, I did that right. Let me just undo it because I get back to where I was. Okay. So, so you go over 1 up 3, over 2 up 12. Over 3 was 3 squared is 9. 9 times 3 is 27. So that's way up here. So you quickly run out of space. And the same thing applies here. You're going to have 3 and 12. And the other one's off scale. Now, here we could go by a factor of 9. So instead of going over 1 up 1, we go over 1 up 9. Right there. But you can see also another way I can think about it is that compared to my standard function, I only have to go a third of the way in the x direction. So this is how far I had to go on the standard function. So to get the same result, I only have to go a third of the distance. So instead of 3 here, I'm 1. If I put 1 in here, I'll have 3 times 1, which is 3. 3 squared is 9. So there. So what we're doing is, you could think of it as we're either stretching it this way or we're shrinking it that way. So we're shrinking by a factor of 3, but we're in the x direction, but we're stretching it by a factor of 9 in the y direction. Oh, I did have a piece of big graph paper for that. Same thing here kind of applies to the square root. And I have a piece of paper for that too. So the standard function, the square root function, starts here at 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. And that's it. We don't have any symmetry to this thing. So what happens in this case is that we multiply each one of these results, y results, by 3. So the second one here is going to be over 1 instead of over 1 up 1. It's going to be over 1 up 3. Instead of over 4 up 2, it's going to be over 4 up 6. 1, 3, 4, 5, 6. And instead of over 9 up 3, it's going to be over 9 up 9. So all of these are 3 times. So 1, 2, 1, 2, 3, 4, 5, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is the second one, and I'm stretching into the y direction. Now what happens here is the multiplier is inside the square root. So it says that I only have to move a third of the distance in the x direction to get the same y. So what I have is here, instead of having to go to 1 to get this y, I just have to go to a third. Instead of having to go to 4, here I just have to go to 4/3, which is about right there. And instead of going to 9, I just have to go to 9/3, which is 3. And so those are how these are shrinking in the x direction. The next one would be, this was 9, 3, 9. The next one would be 4, 16, 16, 4, I guess. So when x equals 16, y equals 4. So I wouldn't have to go to 16. I just have to go to 16/3, which is 5 1/3. So if I go up here, 1, 2, 3, 4, 5 1/3, right there. And so you can see what's going to happen. It's going to look something like that. And it kind of makes sense, because another way I could write this is the square root of 3 times the square root of x. So this square root of 3 is between 1 and 3. So this green line is between black and red. So there's always, when you have a horizontal shrink, you can always represent it as a vertical stretch, and the opposite is true. If you have a vertical shrink, you can represent it as a horizontal stretch. And that is it. Okay, and these are the last problems. These all involve plotting functions, and there are no stretches. These are just shifting and reflecting. So we're going to need a piece of graph paper. Okay, so the first one is we need to identify what the parent function is. And in the first three, the parent function is y equals x squared. So let's just draw the parent function. Remember, we'll start, well, since these are all, I was going to say they're all small values, but the reality is that they grow pretty quickly, especially the cube stuff. So we'll just keep the default here from -10 to +10 on the x and y axis. So the parent function starts at 0, 0, 0. Remember, the parent function is y equals x squared. So you have 0, 0, 1, 1, 2, 4, and 3, 9. And you can go the other direction. It's symmetric with respect to the y-axis. So that's your parent function. Now, what we've got is the first one. We don't have any negative signs out here or inside, so there's no reflection. This is just a translation or a shift. And if you remember, the standard form is x minus h squared plus k, where h is the x shift and k is the y shift. So notice, so what it says is negative x equals 3. So this part, negative x, is equal to plus 3. Hence, h is equal to -3. And k you can just read directly. So k is -1. So what that means is we're going to shift this point, the origin, kind of the anchor for this particular parent function, common function. We're going to move it -3 in the x direction, 1, 2, 3, and -1 in the y direction. So that's the point. Now, all the other points are relative to that. This is where the vertex is going to be. So we're going to start here. So you're going to go over 1, up 1, over 2, up 4, 1, 2, 1, 2, 3, 4, over 3, 1, 2, 3, up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you're going to go to the same symmetric the other direction. So we're going to go over 1, up 1, over 2, up 3, over 3, up 9. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have the function. So that is the transformed function. And I think I'm going to just open up the graphing program. We can double check and make sure we don't make any mistakes. I don't want you guys to be confused. So we have x plus 3 squared minus 1. Now on the test, you're not going to be able to do this, but this is just so it's x plus 3 squared minus 1. And you can see, there we go. You go over 3, 1, 2, 3, down 1, over 1, up 1, over 2, up 4, blah, blah, blah. Okay. Let's get a piece of graph paper, start on the next one. So the next one, we have two things happening. three things happening. So you've got that, this is negative h, so we can say negative h equals negative 2, or h equals 2, and here we have k is just equal to 2. So these are the two shifty things. So we'll start with the origin. I'm not going to draw the parent function here. I'm just going to start with the origin. So we're going to move that 2 units in the x direction and 2 units in the y direction. So let's put a little red dot there. Now, what this does, the negative sign outside, it reflects it across the x-axis. So instead of going up like this, we're going to go to down. So we used to go over 1, up 1. Now we're going to go over 1, down 1, over 2, down 4, 1, 2, 3, 4, over 3, 1, 2, 3, down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And again, symmetry is going to hold here. So what I've done is I've gone over 1 and then just come down to that height. Gone over 2, down to that height. Over 3, down to that height. And so this is what the thing looks like. Okay, so let's just double check. So we're going to have negative x minus 2. Okay. So put a negative sign out in front here. Negative x minus 2 plus 2, like that. We'll graph it. So there you can see, shifted 2 in the positive direction, shifted 2 in the vertical direction, it's inverted, over 1, down 1, over 2, down 4, etc. Okay, the last one of these parabolic or quadratic functions. So before we can do anything here, we have to factor out a negative sign within the parentheses. So if you factor out a negative 1, you'll get positive 1. So that negative x becomes negative the quantity x, and the second part changes. So when you factor negative 1 out of here, you get negative 2. Negative times a negative is positive. Okay. So let me just pull these down a little bit. You can do these calculations that I'm doing here on a separate page. I'm just trying to stay in. So here we have x minus h. So negative 2 equals negative h. H equals 2. And k is equal to negative 3. So this is x minus h plus k. Now, the negative sign here means it's going to be a y-axis reflection. But the thing with the quadratic function is it's symmetric around the y-axis, so really that doesn't affect anything. And I'll show you that in a second. Basically what happens is if you square this, the negative squared becomes positive, and then this just becomes x minus 2 squared. So this negative really doesn't do anything when it comes to quadratic functions. But here we start at the origin. Let me put negative 10. Forgot to do that in the last one. Some numbers on my axes. Label them here. Okay. So we're going to move the origin 2 units in the x direction, positive, negative 3 units in the y direction. As I said, this y-axis thing, because it's symmetric around the y-axis, nothing happens. So we just do the same thing. It's pointing upward, so you go over 1, up 1, over 2, up 4, 1, 2, 3, 4, over 3, up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then use symmetry, over, up, up, over, up, like that. So the function looks something like that. Okay, so let's plot that. So what we do is we take that negative off the front, and It's going to be negative here. So it's the quantity negative x plus 2. So change that to plus 2 squared and then minus 3. And we graph that. And there you go. Over 2, down 3. But let me just show you, if we write the term in the parentheses instead of negative x plus 2, we just have x minus 2. X minus 2. You'll see nothing changes. Same graph. Okay, so that's quadratic functions. There is something happening when you reflect across the x-axis, but for the y-axis, nothing really happens. And it's not like you can just, you do have to take this factor, this negative sign out to get this thing correct. That's where people make their biggest errors, is forgetting to do that. Okay, next one. So the parent function here is the cubic function. So parent function or common function is y equals x cubed. So let's just draw that on the graph. Again, we'll go from minus 10 to plus 10. So 0, x equals 0, y equals 0. X equals 1, y equals 1. X cubed equals 1. 2 cubed equals 8. And then you can go the other way. So this one is one that's symmetric around the origin. So what we have here is we have a negative sign out here, and here we have a negative sign inward. So this is going to have an x-axis reflection, and this one's going to have a y-axis reflection. So again, what we have the same, x minus h is standard form. So we have that negative h equals 2 or h equals negative 2. And from this second part, we have k is equal to 2. So that's how we move the origin of this. So we're going to go minus 2 in the x direction, plus 2 in the y direction. Okay, now, if the negative sign wasn't here, we'd have the same shape and the same orientation. But because of the negative sign, this is going to flop down here. This one's going to flop all the way down here. So instead of going over 1, up 1, we go over 1, down 1, over 2, down 8. 2 cubed is 8, so over 2, down 8, 1, 2, 3, 4, 5, 6, 7, 8. And because this is symmetric around the origin, here the parent function, we went over 1 to the left, down 1. Here we're going to go 1 to the left, up 1, and over to the left, up 8. So those are the 5 corresponding points, and then we can kind of just sketch that in like that. So it does flip over. It gets shifted. Okay, so let's pull our graph up here. What do we have? We have negative x plus 2 cubed. Negative x plus 2 cubed plus 2 plus 2. And I'm going to increase the y to be from 0, negative 10, to positive 10. So there you go. There, it looks just like that. So you shift the origin from here to over 2, up 2. And because of the negative sign, instead of going like this, it's going to flip over and go the other direction. Okay. Now 26, again, you're going to want to, because there's a negative sign in front of the x, we're going to want to factor out a negative sign. But first, let's just change the order. Addition, doesn't matter what order it's in. So negative, instead of 4 minus x, we have negative x plus 4. And then we factor in a negative sign. So you get negative the quantity x minus 4, quantity cubed, plus 1. Okay, so that's good. So what we have is that negative h is negative 4, or h equals 4. And here we have k equals 1. So let's add a page and put our graph. So we go all the way down to the bottom again. And this negative sign inside the parentheses means we flip it around the y-axis. So what's going to happen is things that are over here are going to go over there. And things that are over here are going to go over there. So let's first shift this anchor point, that I call it, the appropriate number of units. So we go 4 in the x direction, 1, 2, 3, 4, and 1 in the y direction. Okay, so that's our new point. Now, normally, the parent function, we go over 1, up 1. But what's going to happen is this point, instead of going down, flipping down this way, it's going to flip over that way. So it's going to essentially do the same thing, except, so this is what we're basing on. So this point, over 1, up 1, now is this to the right 1, up 1 is going to go to the left, up 1. The one that was to the left, 1, down 1 is now going to go to the right, down 1. Okay, and then we go over 2 and up 8. So that ends up being here. And then we go over 2, down 8. So that's going to be to here. So we go over 2, down 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so those are our points. And again, we flatten off here at the origin and then turn the other direction and keep going down like that. And just to confirm this, so we'll take that negative off the front. In the parentheses, we have 4 minus x cubed, and we have plus 1. Plus 1, graph. So there it is. 1, 2, 3, 4, up 1, so that's that point. And then we go over 1, down 1. 1, down 1. So this point corresponds with that point. This point corresponds with that point. Okay, so that's the first bunch. Let's go to the next bunch now. Oh, we have one more cubed, which is actually the easiest one. So there's no reflection here. So all we have to do is say negative h equals negative 1, or h equals 1, and here we have k equals 3. So we're going to shift 1 unit in the x direction, 3 units in the y direction. So that's our new origin. From that new origin, we're going to go over 1, up 1, over 2, up 8, which is actually going to put us right outside. 3 plus, 1, 2, so 1, 1, 2, 3, 4, 5, 6, 7, 8. You go to the left, 1, down 1, 2 to the left, down 8, so 1, 2, 3, 4, 5, 6, 7, 8. So those are the points. Then you kind of just sketch through them like this. And do that. Okay, double check it. X minus 1 plus 3. Okay. So we're going to have x minus 1 cubed plus 3. Graph it. There it is. So this 1 over 1 up 3 over 1 up 3. That's that point. So this corresponds to that. This corresponds to that. This corresponds to that. Okay, the next two are absolute value. We could do 29 first because that's actually a simpler case. And again, this part here is negative h. So negative h is equal to plus 2, or h is equal to negative 2, and then we have k is equal to negative 3. Now for the absolute value function, the parent function's pretty easy. It's just two straight lines that go diagonally like this, like that, and then like that. So that's the parent function, which is y equals the absolute value of x. Now there's no negative sign out here. There's no negative x inside there. So in this case, all we have to do is translate this and draw it exactly the same. So negative 2 and negative 3, so that'll put you there. And then at that point, you can draw a diagonal line here in the same way, the other way we're drawing it, right through these corners, over 1, up 1, over 1, up 1, over 1, up 1, that kind of stuff. And let's just plot that. What we'll do in this case is we'll plot both of them. So we have the absolute value of x, which is a common or parent function, and then we have the absolute value of x plus 2 minus 3. So there it is. Looks pretty close, doesn't it? Okay. Now the next one, the negative sign is outside the argument. So this one means you have a x-axis reflection. Now the absolute value is kind of like the squared thing, in that if you have a negative sign inside the absolute value and you factor that out, not out of the absolute value but outside of the x part, you're not going to see any difference because the absolute value is symmetric around the y-axis. So that doesn't really do anything. This one does. This is going to make it point downward instead of upward. So again, negative 1 is equal to negative h. H is equal to 1. In this case, k is equal to 2. So the pointy part is going to move. We're doing this one now, 28. It's going to use 1 unit in the x direction, 2 units in the y direction. And rather than pointing up like this, we're going to go the opposite way. So it's going to go down, run right diagonally through these things. So you go over 1, down 1, over 1, down 1, 1 down. And likewise in the other direction, same kind of thing. The reason I'm just sitting here thinking, notice this one is, if we go back to the parent function thing, it goes through these top two corners. So because this is shifted 1 over, we should go through there. What I was thinking was, this is moved up 2 units, so why doesn't this go through? Oh, maybe it's because it's shifted over 1 as well. Maybe that's why. I mean, it does go straight through there, so I think it's fine. So the negative here flips it around. If it didn't have the negative sign, it would go this way, upward. Okay, let's check it out. Negative. So we're going to have negative the absolute value of x minus 1 minus 1 plus 2. So there it is. So you go over 1, up 2, it's upside down. Okay, and the last 2 or 3 here, 3 are square root functions. So Let's draw the parent function. 0 square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. So that gives you, so that's my parent function. So the first one, I'm actually going to do, I guess all of these I need to, they've all got some kind of reflection involved. So let's take this first one. We'll move these two down a little bit. Give me some more room to work on it. So the first thing I would do is I would just change the order like that, and then I would factor out the negative sign. So I'd have negative x minus 2. Now, negative h equals negative 2. I don't do it up here. I have to wait till I factor this negative sign out. So if I solve for h, it's going to be 2, and k is going to be equal to 1. So let's do that first. So you go over 2, up 1. So that's the new origin. Now, the question is, does it go like that? Does it go like that? Does it go under? There's 4 different ways for this thing to go. Because you've got the negative sign inside the square root, it's going to be a y-axis. So it's going to rotate. It's going to reflect this way, because we normally reflect. If we reflected this function across the y-axis, this would go over there. So instead of going over 1, up 1, going right, up 1, I'm going to go left, up 1. Then we're going to left 4, 1, 2, 3, 4, up 2. I'm going left 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, up 3. So those are my 4 points. There you go. Okay, so we have the square root of 2 minus x plus 1. Square root of 2, I already forgot what it was, 2 minus x. 2 minus x plus 1. Graph that thing out, and there it is. So you can see 2, 1, 2, 1, then you go over 1, up 1, over 4, up 2, over 9, up 3. Square root of 9 is 3, square root of 4 is 2. Okay, so that worked. The next one is you're reflecting both across the x and the y-axis. So the first thing we're going to do is we're going to factor this negative sign out again. So that'll become negative x minus 2 plus 3. So when I factor the negative sign in out of this, it becomes positive x. And when I factor a negative 2 here, it becomes negative. And again, you can think negative 1 times x is negative x, and negative 1 times negative 2 is positive 2. So now we can say that negative h equals negative 2, or h equals 2, and here we have k is equal to 3. So let's get a piece of graph paper, clean piece of graph paper, stick it in there. I'm going to use green this time. So we're doing this one. So it says h is the x shift, k is the y shift. So there's my new axis, or my new anchor point. Now, what's going to happen? This is negative sign, means that it's going to well, this negative sign means it's going to reflect across the y-axis, and this one's going to be across the x-axis. So if we start at, let me just do if I was a parent function going like this, reflecting it across the x-axis would cause that, and then reflecting that subsequent one across the y-axis would make it go that way. Okay, so I know it has to go this general direction. I just have to count now. So here's my starting point. Over 1, down 1. over 4, 1, 2, 3, 4, down 2, over 9, square root of 9 is 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, down 3. So there you go. So go through those points like that to there. I can erase this other stuff. So here it is, negative quantity, negative x plus 2. So put a negative in front of there, negative the quantity, negative x plus 2 plus 3, plus 2 plus 3. And we graph it. There it is. So you can see it starts here, over 2 up 3. That was over 2 up 3. We go to the left, down. That's that point. 4 to the left. 1, 2, 3, 4, down 2. That's that point. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's another one, which would be this point. So we can move to the left. So you can see there it is. This point corresponds to that point. And with those 4 points, we can sketch it in. And then the final one is this one. And this one only has one negative sign. So it's going to be reflected, because it's out front, it's going to be reflected across the x-axis. So instead of going up to like that, it's going to go down. So this is a normal one. This is what we're going to look like after you reflect it across the x-axis. So we'll come back to that and put in the exact values. So we don't have to do anything as far as factoring anything out, but you know, this part plus 2 is equal to negative h. H equals negative 2. Here we have k is equal to 2. So we're going to shift the origin, negative 2 in the x, plus 2 in the y. So we're going to start there, and then we're going to go down to the right. So I'm going to erase these things, and I'm going to go over, down 1, over 4, 1, 2, 3, 4, down 2, over 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, down 3. And then I can start here and draw, sketch through this. So I've got negative x plus 2 plus 2. So we've got the negative sign, x plus 2 plus 2. So negative the square root of x plus 2 plus 2. I graph that. Here it is. So you start here at negative 2, positive 2. You go over 1, down 1, over 4, down 2, over 8, over 9, down 3. So those are the 3 points. 4 points. 0, this one here, and you sketched it. Okay, so that's it.